Alrighty, welcome to the Besides the Norm podcast. My name is Scuba. We've got Monk over on the side.
What is happening?
Not very much. I'm just kidding. We have a podcast to do.
Yes.
We will we'll steer away from the usual amazing banter at the beginning.
Aye.
And we will get on with the thing that we're doing today. We have on the line Dr. Katrine Wallace. How are you doing, Katrine?
Hello, thank you for having me.
Am I pronouncing that correctly?
Yes, you are. Actually, you're one of like 10% of people that actually say my name correctly. It's Katrine.
Yes.
Probably because you're Scottish. It's a Scottish name.
So
that
the
is
other
not
people
like
say
me.
Katrine?
It's like the lake, right? There's a lake there named that. That's where my mother got it from.
Right.
Okay.
Nice.
That's fine. So, so I've been practicing this because the line of work that you do is a horrible word for me to pronounce a lot of the time. So, enjoy this for what it is. So, Dr. Katrine Wallace, Doctor of Epidemiology, University of Illinois.
Alan White, you've messed up.
That's where I mess up. Unbelievable.
Now that you didn't pronounce right. No, I'm just kidding.
That's the first time I've messed it up.
I work at University of Illinois at Chicago.
You got epidemiology.
Oh my god.
You got that one right. Yeah, that one's good.
The one I've been struggling with, and I messed up Illinois. Unbelievable. Okay. So
that's okay.
So it says here on your Twitter, PhD and MS. Could you explain what those are?
Oh, sure. So I don't know how it is in the UK, but in the US, the MS degree is a Master's of Science degree. Okay. So I got that en route to my PhD, which is the doctorate in public health science, and my concentration area was in epidemiology and biostatistics.
Okay.
Wow.
Perfect.
That sounds complicated.
Yes.
I'm already intimidated.
Well, this is great.
No, it's mostly just stubbornness, not really smarts.
Right, I'm sure. Okay.
Just really concentrating on stuff. That's all that is. So yes, we've got you on. We will be talking again.
Shock.
Yes, mainly about COVID. There's a lot of COVID questions we have in.
Yes.
I assume you knew that.
Yeah, that's usually why people want to talk to me these days. Before COVID, really nobody knew what an epidemiologist was, and when they would ask me what my job was, and I said I was an epidemiologist, people thought I was a skin doctor, like epidermis. And only now, so I enjoyed my career as a skin doctor, a fake skin doctor, but it's now over, and my cover has been blown, and everybody now knows what I really do, thanks to COVID.
Fantastic. Thank you, COVID. Unbelievable.
Yeah, now epidemiology is a household word, but it wasn't before.
Okay. Well, that's perfect. So what we'll do is, could you explain, Katrine, a bit about your background and how you got into this line of work?
Sure. So basically, I was a science person kind of all along, like in my undergraduate, my bachelor's degree was a science degree. And then I started to do work in, actually I worked in the pharma industry when I first graduated, and I worked on clinical trials. And then I kind of really got to enjoy more real world data, not experimental data. So collecting data that was more like epidemiologic in nature, like exposures, looking at outcomes, sort of like smoking and lung cancer. Like I was more interested in that than clinical trial data. So I started to work more on those kinds of studies. And then in the process of that, I got more interested in studying epidemiology and then ultimately teaching it.
Mm-hmm. I could already hear the conspiracy theorists' butts clenching a little bit at the idea of the word big pharma.
My clinical trial days are way long ago, but that was just my first, how I kind of cut my teeth in research, I guess. Yeah, exactly. Everybody works for big pharma or the deep state. Those are the two.
Yeah.
I love the deep state.
That I hear the most. Yeah, I haven't gotten my check from the deep state yet. I must call their 800 number at some point. Inquire about that.
I used to be a conspiracy theorist, but when I was a conspiracy theorist, it was just...
Then you grew up.
Yeah, I grew up. It was the Freemasons and the Illuminati back then. And that seems to,
that seems
to have
Well, see,
disappeared.
that's when conspiracy conspiracies were fun, like Elvis is alive and Paul McCartney's dead, and like those were the fun conspiracy theories. Now they're damaging and harmful, right?
Yeah.
Good old moon landing. That was my thing.
Bring back the triangles is what I say.
Yeah.
That's it. That was good old days.
The Eye of Horus being
the Eye of Horus,
everywhere.
yes.
Yeah, that was great.
Listen,
Like we didn't really go to the moon, and like all these ones, like
that was my favourite one. The moon landing was my favourite.
Yeah, but I mean, those won't hurt people. You know, the problem now is that the conspiracy theories, like COVID isn't real, is actually harmful because people who believe these things will behave based on the conspiracy theory instead of on the public health guidances, and that's the kind of thing we struggle against.
I figured out last night that there's a conspiracy theory that AIDS isn't real. Did you know about this?
Oh, well, let's. Yeah, I mean, there's probably a lot of people from the 80s and 90s that we could wake from the dead and let them know that that's true.
Well,
like they would probably be interested to hear that. Like, what?
The thing that worries me is this person seemed to be roughly the same age as me, and I was born in the 90s. So they seem to have just missed school.
Yeah.
I don't know what's happened there.
Just skipped past
I don't know what the benefit is to AIDS being made up.
I don't know.
No, there would not be one.
I know during that time period there was a lot of gay men at the time were like, "This is the state coming after us," sort of thing. This is a thing they're spreading around to give us more hate and stuff like that.
Right? Okay.
Yeah. But madness.
Yeah.
Madness.
Nonsense.
Okay. So what do we want to move on and start with first, Craig?
What could you explain exactly what epidemiology is?
Mm-hmm.
Oh, sure. Yeah, that's a great question. Yeah. So epidemiologists, we have basically three roles. We look for, we count cases of disease. So there's epidemiologists that study any disease that you can think of. There's people that study infectious disease. There's people that study chronic disease like heart disease and cancer. And we basically count cases. That's really important because incidence rates, new cases of disease, basically tell us how fast and where a disease is spreading or happening. So that's the first really important thing that we do is just counting cases. Right. And the second thing we do is we look for risk factors for diseases. So first we find out where and how fast things are spreading, and then we find out why. We try to find the why. And then the third thing is that we try to put in prevention measures. So it's kind of a stepwise process. Like you count, you figure out why it's happening, and then you prevent. So that's basically the epidemiology is like the science of public health, where we do that kind of analysis.
Right. Okay, so in the scheme of COVID, that is a lot of work.
Definitely.
Has there been?
I'm sorry. I didn't hear the first part of what you said.
Oh, so in terms of COVID, that seems like an awful lot of work because this seems to be happening very quickly.
Yes. So one thing that's been very interesting is that this is some people's first kind of glimpse into public health because really most of the time when you're going about your daily life, you're not thinking about what public health organizations are doing because real good public health work is oftentimes invisible. The reason we don't have tuberculosis or cholera outbreaks and things like that is because public health is working and there's people that are dedicated to all these different diseases. There's people that are working on smoking cessation and there's people that are working on heart disease prevention. And there's all these messagings that you see like on billboards and things, just seat belts in cars and speed limits, like all this public health is kind of working in the background and you don't think about it. But when COVID hit, all of a sudden, everybody, because it was so high profile, got to kind of watch along and see the science develop and sort of like watch us make mistakes and put things into place and change guidelines and do, because we were kind of moving at the speed of science. And it's been people's first instinct to kind of criticize public health agencies, but I think people don't realize how much is actually at work in the background of your life, but you just don't see it.
that became very clear on the science of masks because...
Oh, God. Yeah.
Yeah, at least in Scotland, the initial, and I'm guessing that this was a worldwide thing, the initial advice was not to wear a mask, partly because they were needed for health professionals and they were worried about a shortage.
So we had a global shortage of masks at the beginning, and this was before people were kind of making them in their homes, right?
Yeah.
So those blue surgical masks, we had a global shortage of those, and the healthcare workers, like you correctly state, needed those at the beginning. And another important part of that is that at the beginning of this, we didn't realize how much asymptomatic and pre-symptomatic spread COVID was associated with, because we were used to other respiratory viruses that had less of that asymptomatic, pre-symptomatic spread. So we didn't realize the importance of community masking until later, when we realized there was that component. And then when people started wearing the cloth masks, of course, like you're saying, the guidance had already been one way, and then when we changed it, it was problematic.
This is one of the things that sort of bred a lot of these conspiracy theories, is the fact that you guys are also learning on the job as you go along, like these things.
Exactly. Exactly. So we're all moving at the speed of science, and usually it's not so high profile, right? Usually these things are kind of done and put out and nobody's thinking about it. But right now, because everyone's laser focused on everything that we're doing as public health people, you're right. So it's more high profile than it ever normally would be.
Mm-hmm. There was also something about droplets. Was that part of why mask advice changed?
So, yes. So we know that, so let's use influenza as an example. So the flu is a very significant worldwide health problem. We have mortality associated with the flu. It's, one of the leading causes of death in, pretty much any country that is associated with the significant flu season. So with the flu, another respiratory virus, when you have symptoms, like, you pretty much are infectious. That's how it works. And so most of the time when people are sick with the flu, hopefully they stay home. With COVID, there was this significant portion, 20% or something, of people that have this asymptomatic case or pre-symptomatic, and they're not yet experiencing symptoms and can walk around in the community without realizing that they're sick. And that's the difference, kind of. And I think the reason that people were like, oh, if you aren't sick, you don't need to wear a mask, because we didn't realize that people wouldn't know they were sick. Does that make sense?
Yeah, that makes sense.
Yeah.
There was also a thing that came out, I'm kind of losing track of time, but I think it was the WHO that released a statement and then sort of went back to clarify the statement of the difference between pre-symptomatic and asymptomatic, because apparently asymptomatic people spread less or something.
So we have, yes. So there's this. So the difference between the two, just for your listeners, is there's pre-symptomatic means that I have been infected with COVID and I'm walking around and I'm feeling totally fine, but I'm going to get symptoms in a couple of days. Asymptomatic means that I am infected with COVID and I'm never going to get symptoms. So there is a belief that the asymptomatic people spread less virus because they didn't get enough virus to become symptomatic in the first place. So that's not completely been fleshed out in the literature yet, but that's the hypothesis. Okay.
So, as a perfectly smooth transition to the next question, there was a difference in droplet. Oh yeah, I remember what it was. Asymptomatic people, I assumed, were spreading less because there wasn't as many droplets. Is there any science in that?
Mm-hmm.
Right. So that's a really good point, because the primary way this virus does spread is through respiratory droplets. And that is why it's so important to always wear a mask, because the mask protects your droplets from getting out into the community. So masks, we call it source control. So it keeps your droplets in. So there's a really profound misunderstanding of how masks work. People are like, well, I wore a mask and I still got sick. So, but that's not really how they work. It works to keep your droplets in. So they work if everybody wears one. It's a community effort. So it's like a public health effort. There's a second way that the virus can spread, though, and it's aerosols that come out when you're just normally talking, singing, working out. So it's like it's less associated with being sick and symptoms of being sick. So, for example, we have data showing that group fitness classes and choir singing are associated with higher rates of COVID spread in asymptomatic people because they're kind of exerting and breathing heavy. Right. And also aerosols can kind of hang in the room like after the person has left as well. So it's important to always wear a mask because of these things. But you're right that mostly it spreads through respiratory droplets. That's the primary route of person-to-person spread in COVID-19.
Because we actually had COVID for a little while as well.
Yeah.
It was pretty much almost
inevitable. Oh, that's right. You told me that on your email.
Yeah. It was almost inevitable that you were going to get it as well.
Why?
Pretty much. Well, just through droplet, because we're always
just because I'm very unlucky, yes.
And that, yes. But we're constantly interacting as well. So it was just basically inevitable that was going to happen.
But what annoys me, though, is that I wore my mask, I stayed 6 feet away from people. I specifically told people to stay 6 feet away from me, like I wasn't hesitant to tell people to move. And I never went out, I never went to parties, I never done any stupid stuff, and I still caught it. Mm-hmm. I was really annoyed at that. Mm-hmm.
It's not fair, that's because like what you're saying, and I'm glad you brought that up, is that masks don't work by themselves, right? Yeah. We know nothing is 100% effective. So it's not eliminating risk, it's mitigating risk. So there is still a risk. There's not going to be zero risk, but the more mitigations that you can put into place, like you're just describing, you wore a mask, you use the 6 foot distance, the more, so we think of it as like a Swiss cheese model. This is how we describe it, and then this is what I do in my classes, where you have layers of Swiss cheese. Like there's you on one side, and then maybe all the layers of Swiss cheese in between you and the virus. So masks is one layer, but there's holes in the Swiss cheese, so there's some of the virus can get through. But then you stick another layer in, and that's the 6 foot distancing. Hand washing is another one. Isolating when people are sick is another one. Quarantining when you've been exposed is another one. And then we'll have vaccine in there too. So it's like a Swiss cheese model, so that there is ways the virus can still get through, but comprehensively as a mitigation strategy, all those things working together are more effective. But as you said, nothing's 100%. So it's, there's going to be those times when even at your best efforts. And then you see your friends running around and posting Instagram stories, and they're like, why didn't they get sick? Because they're not taking any precautions. It's like makes no sense sometimes.
The Swiss cheese explanation completely, I was thrown away by on your Twitter you have a picture of slices of Swiss cheese. I was confused earlier, but that explains it. So that's
also,
perfect.
There's a funny coincidence in the Swiss cheese model, in that we caught COVID. According to the track and trace people, it seems that we got COVID going to one shop that we only went to get cheese.
Oh my gosh, I'm going to use that story. I hope you don't mind.
That's absolutely fine.
Really, it's like there's no justice.
Yeah,
no justice.
We hadn't been to that shop since March, and we got COVID in October.
Yeah,
unreal.
And it was stupid, really. Actually,
I don't know who's the controlling force on this planet, but he's no.
Well,
nice.
I don't know about anybody else, but I considered cheese to be essential. So
yeah.
Jesus. That's it.
Oh, God. Oh,
Sorry, I
no.
will never do it. Oh, sorry.
Oh, no.
Okay.
That's funny.
So, at the beginning, I was trying to put my questions in a specific order because my plan is to then, later on tonight or tomorrow, do a proper series on Facebook of each question being answered. But I've already broken.
that's good.
I've already broken that order.
Well,
so I may as well just ask.
We could do some of this with the questions that come
Yeah.
up.
So my next
Good
question
with
is
whatever.
this question is a question that I asked a council member here, and I didn't expect him to know, but it was for when things were opening up in the summer. And the question is, swimming pools. What is the deal with swimming pools? Because they have chlorine in them. Does that protect from COVID, or is it still just a big COVID soup?
So like we just discussed, the main way that COVID spread is through respiratory droplets. So you're more likely to get COVID from the person swimming in the lane next to you than you are from the water. I don't think I've ever heard of a waterborne COVID infection, to be honest. Like a cholera that is a waterborne illness. COVID is a respiratory virus. So if you're swimming, heavy breathing in a lane next to somebody, you could give that person the disease if they breathe your respiratory droplets because you're swimming next to them and exerting. So that's why I don't know how it is there, but in our area, we have 25% capacity in gyms, and in pools, they can't be, the lanes cannot be right next to each other.
Right. I actually don't know what things are very different here, like every week. So I don't know how much you know about the politics in this area, but the UK is 4 different countries, and they each have their own little sections, and each tier's changing.
I do know about that.
Yeah. So it's kind of sometimes it is beginning to become hard to keep up with what's open where and when and So
it's sort of the same here. Our politics, actually, the UK and America, I feel like is the polarizing politics is very similar.
Yeah. I would characterise that as accurate.
Right, okay, well, do you want to go into the questions? Do you have an extra couple? I was just going to go on by...
I've got one more question that's not written down. What is the... I don't know if I need to go into a backstory. I'll just ask the question straight. What is the view from an expert's opinion on full lockdowns?
On lockdowns?
Yeah.
Well, I can say from a public health perspective that we have seen evidence that they work. If you look at countries like Australia, New Zealand, China, South Korea, we've seen evidence that they work because the main reason, if you just think sheer biology, the way the virus spreads is from person to person. And if the viruses can't find hosts, it's not going to replicate. That's just the basic, very bottom line of why they work, right? That's the ultimate mitigation strategy. Get the people away from each other, the virus won't spread. Now, that being said, I get a lot of criticism that I am pro-lockdown. In the U.S., we have there's a false dichotomy that's been set up in the U.S. where any public health mitigation strategy, whatever it is called a lockdown. Yeah. People are like, you say, bars are going to start closing at 10. Then you have people, we're back in the lockdown. It's like, it's the dramatics of the whole thing. It's everything's called a lockdown and everything. So there's this idea that we either lock down or we just do nothing and let the virus spread. Whereas public health doesn't want either one of those things in the U.S. anyway. I think it's the same in the UK where we want like the Swiss cheese model, the mitigations, as many things as you can put into place, but we don't want to lock down. I mean, like places like New Zealand, they locked down severe. I mean, they closed down everything that wasn't like a grocery store, a gas station, or a healthcare facility. You couldn't even order things online that would to be delivered to your house that weren't like essential products, like food. So, I mean, that worked for them. And, you know, they were able to do that because they actually like, you know, had a good payment plan for their people while they did that. Like, we don't have that in the U.S. So we can't really we can't just close down our entire economy because people wouldn't be able to pay their rent, you know, or eat. So it's not feasible in a place like America. That would have been feasible in like New Zealand. However, like if we all work together as a community and put the mitigation strategies into place, you don't really need a full lockdown to get results. It's just unfortunate because we have a lot of people that kind of push back against the public health recommendations, and public health recommendations have become like anti-economy somehow, when in reality, the economy is really not going to rebound until we're done with COVID. So it's like the public health is like the way out of this and not really the enemy.
I have one final I lied. I have one final question before the written questions. Why does COVID seem to only affect adults and not really children as much?
You know, we really don't understand enough about that to have like a real good reason. And I don't know. You're right. That's what we've seen. But in terms of a scientific rationale, I've kind of seen a few things posited, but nothing's been replicated with different studies.
I mean, there is, I can't remember the name of it, but there is apparently another infection that's similar to that, and that kids don't feel anything, and then they go home from school or nursery or whatever, and the adults get really sick. So that has been seen
exactly,
a couple
and
of times before.
we have the problem in the U.S. with multi-generational homes in a lot of urban areas, and that's the concern.
Yeah.
Those people living with grandparents in the home.
But do kids spread it as much as adults? Because that's always been
kids
sort of
do spread it. The idea I don't know where that came from, actually, that children don't spread COVID, because it's not true. I mean, they spread it just like everybody else. They might not have as severe cases.
I fell for the idea that kids didn't spread it.
Yeah, I think that might be a U.S. thing. There was definitely that rhetoric going around that kids can't spread COVID, and it's definitely untrue.
Okay.
Well, Craig, you don't know everything.
Yeah, I'm an idiot.
So
I'll fix that in future.
No. We know like that.
Do you want to go through your questions first?
I've asked 3 million questions. You ask some questions.
Okay, well, these are from other people. So,
yeah, I know.
So we'll go with these. Do you trust and will you have a rushed vaccine? This is from
I do
Claire.
trust it, and I can't wait to get it, to be honest. There has been this kind of fear, I guess, that it's been rushed. Mm-hmm. But to allay people's fears, I mean, the mRNA technology we have had, I mean, it's been being developed for years. It's not new. They were trying to do it for SARS. They started developing vaccines with it. I don't believe any of them are on the market, but these have been studied. It's not a brand new technology that we came up with like this summer or anything like that. So they have been kind of, and that's why we were able to kind of use that and develop this so quickly, because there were mRNA vaccines already in development that could be used for other coronaviruses. Yeah. So it's not like they started from a blank slate. There was work already done towards this, before this came. So that's number one. Secondly, what is perceived to the public as having been rushed. Usually vaccine trials take years and the reason they take so long is really enrollment of subjects and getting interested subjects. So the enrollment phases, like of a phase 3 study, can take really anywhere from 0 to 3 years to enroll the patients. And we took there was so much interest in being part of these trials that the enrollment took not even 1 month to get these people enrolled. So that's significant time savings right there. And the approval, manufacturing, all of that stuff, the sort of more bureaucratic regulatory, that has also been kind of cut from 2 years to down to about 6 months. So what seems like rushed is really a lot of kind of cutting out steps that are usually in the process but with this emergency kind of situation, we've been able to circumvent a lot of that. Now, in the UK, the Pfizer vaccine was actually approved today via the emergency use provisions, which that is another way that things have been sped up. And that's not to say that it's cutting anything out. It's saying that we're looking at the data at its face value right now today in an emergency situation where there's an unmet need, and we're going to continue to monitor. They won't get full approval until they follow up on those patients until the end of the trial, which is 2 years. So the things that seem rushed are actually more just cutting out time or doing things in concurrent time.
Mm-hmm. It's quite interesting to know that, since March is really when it hit here, that and all that time.
It's really a triumph of science, to be honest, that we have a vaccine already, ready to go. It's really amazing.
I was waiting until mid next year or something like that. That's what I was expecting. Yes. I mean, I think that's probably realistically when people like us will get it, probably spring, late spring. But I mean, the highest risk people in the U.S., I don't know how they're prioritizing in the U.K., but in the U.S., we're prioritizing healthcare workers and people that live in long-term, skilled nursing homes and things like that.
Here it's that and people over 85 first.
Yeah.
There's 9 different
Oh, okay. So
sections.
You're doing that age group first. Yeah. And I think our elderly community dwelling people will be next after the 2 groups I mentioned.
Right. It's an odd thing to know that our First Minister said that if all things going well, deliveries and stuff happen, that the first person will get the COVID-19 vaccine on the 8th of December.
I know.
That's 6 days away.
It's crazy.
It's Tuesday, isn't it?
It's crazy.
Something like that. I don't know maths.
It's really very exciting. The difference between the two, so there's 2 vaccines that are being considered for emergency use authorization in the U.S. I assume it's the same in the U.K. It's the Pfizer vaccine, which you guys got approval for today, and the Moderna vaccine, which is another mRNA vaccine. So the Pfizer vaccine has to be kept at an extremely cold temperature, and they need a special freezer to keep it in. And so I think Pfizer is, from what I understand, people are already getting those freezers shipped to them to keep in the pharmacies. That needs to be kept at a negative 75, which is kind of very inconvenient. So it's not like they can give that vaccine in a regular chemist, right? Mm-hmm. So it would need to have that special freezer technology. So the Moderna vaccine also needs to be kept in a freezer, but that one needs to be kept at negative 20 C. So that's less. It's not like a crazy freezer that it needs to be kept in.
Does it get injected? Does it get injected at minus 70? While it's minus 70?
I was going to ask that, but I was scared it was a dumb question.
It sounds cold.
No, it's not a dumb question. It's not a dumb question at all. So each, I believe, and this could be wrong, but I'm going to say what I think it is. So they're each frozen container contains, I think, 4 doses, and you have to use them all because you can't refreeze them. So I don't believe that you inject it frozen because you have to, I think it only lasts thawed for a certain amount of time before the mRNA kind of comes apart. That's why it needs to be kept at such a cold temperature.
Right, okay.
It only stays stable for a certain amount of time thawed. And the Moderna is a little bit more, the mRNA itself is a little bit more stable, so it can stay at a less cold temperature. That's why the storage temperatures are different, I believe.
Mm-hmm. We'll just go to the next one.
Huh?
Excellent. Why are children with?
I'm not like an expert on shipping and that kind of supply chain stuff, so that's just my understanding.
That's fine. Why are children with weaker immune systems avoiding the virus?
With so anybody, not just children, but anybody that's like immunocompromised or have autoimmune diseases should be careful of viruses anyway, because they could be at risk for severe outcomes.
I've got a question because we were talking about vaccines. Colin asked, what percentage of the population needs to be vaccinated to see a reasonable level of herd immunity? But there's a second part to that question. Can that percentage change based on population size and density?
That's a good question, actually. So the reason that we try to get as many people vaccinated as possible is because there's always going to be people in the community that are too old, too sick, or too young to be vaccinated. So the rest of us get vaccinated to protect these more vulnerable members of society that maybe won't be able to get the vaccine for those reasons. And it's not just true for COVID. This is true for any vaccine. Yeah. Mm-hmm. So that's why, and so when enough people in the community have the vaccination, it will stop the virus from spreading in the community, and it will be less easy, like we said, for that virus to find a host. And we call that level of protection in the community herd immunity. And this is really a vaccine concept that, and we've had threats to our herd immunity for diseases like measles because there's a lot of vaccine hesitancy that's been arising in the last 20 years in the U.S. And I'm sure there too. Yeah. I just know about it here. So we're really hoping to do kind of a good education campaign around this COVID-19 vaccine because we already know the long-term effects of COVID can be very severe. We've got, respiratory complications, renal complications, cardiovascular complications and who are they happening to? Otherwise healthy people who were healthy enough to survive the virus in the first place, right? And we are only just now scratching the surface of what we know about the long-term effects of COVID. So making sure that we're vaccinated and protecting those vulnerable members as well as ourselves is going to be important. Oh, and the percentage, you asked about the percentage.
Yeah.
So I've seen estimates about 70% of the population is what we want for a target goal. That's that would be great if we could get that.
And density wouldn't change.
More would
that.
be more would. And then what?
Density, so how Australia's really.
Oh, density, right? Yeah. So, interestingly, this virus has such a large reproducibility factor. So, COVID is very, very contagious. It's more contagious than flu and some other not as bad as measles. That's the worst one.
Okay.
But it has a very high, what we call it the R naught value in epidemiology, but it's basically how many people one person is expected to infect. And with COVID, it's a pretty high number. And so we weren't expecting, in fact, in the rural areas of the United States right now, COVID-19 is rampant. And that has nothing to do with density. It's really kind of odd. And it didn't really need to be that way because it started in the cities in the U.S., spread in the cities badly, and then sort of moved its way out to the rural areas. And, not coincidentally, the rural areas in the U.S. are also areas that are resistant to mask wearing and mitigations and things like that. So, that's very highly correlated. For example, the Dakotas in the U.S., North and South Dakota, are they have the highest death rate from COVID-19 like in the world when you adjust it per capita. And they're very resistant to mask wearing and reluctant to participate in public health. So it's very frustrating. So it really has, like we said before, the virus spreads when people are passing it from person to person. Where that happens frequently is in gatherings, in events, in, clusters. We know this disease happens in clusters, super spreader events, parties, in-home gatherings, church services, anything like that. So it doesn't necessarily have to be in a big city to be spreading. Does that make sense?
Yeah. I think you've pretty perfectly described our town, because our town is pretty rural, and there's a lot of people suddenly became asthmatic when they got the out of.
Oh, exactly. And yes. And yeah. And what's interesting is an asthmatic person you would think would want to protect themselves more, because it's sort of like an autoimmune disease that you'd want them to protect yourself from the virus more. Like my mother is asthmatic, very severely asthmatic, has been all my life, and she always wore masks. Like when we went on planes and when we would go to church in like the winter, she would always have a mask on, and I would be embarrassed, and I'd be like, "Take that off, Mom," And when I was a kid, because I was like, "What are you doing?" Like, because no one wore masks, right? And I'm an epidemiologist now, but when I was a kid, I'd be like, "What are you doing?" But she always wore masks to protect herself, because she knew that she could have a very bad outcome if she got a respiratory virus. So that's why it's very ironic to me that asthma is used as the excuse, because my entire life it was used as an excuse to wear one.
Yeah, I've got asthma as well, and I've always worn a mask, and I've never had any issues ever. No. So to hear people saying, "Well, I've got asthma, I can't wear a mask," I'm like, that's not a very good excuse.
Yeah, no, there's really, I'm not going to minimize people that have had like trauma and have hard time wearing, but that's, obviously I have empathy for those people, but when you're in public during a pandemic, you need to participate in public health. And if you can't participate in public health for whatever reason, then you really shouldn't be in public.
Yeah, that's another thing. Like, you would think people that are struggling so much to wear a mask that they can't breathe, they shouldn't be out. You would imagine.
Yeah.
That's kind of. And when I say that, people think I'm being very harsh. Like, well, just don't be in public then. But we're not in a normal time right now. Yeah. And if you can't wear a mask, then you need to figure something out and stay home, because it's getting out of control with that stuff.
Excellent.
I've got another one about vaccines. If you
go, I was just going down my list. So,
do you happen to know? Again, when he asked this is a guy called Dave. When he asked this, I did explain to him that you weren't. I don't know what doctors deal with vaccines, but I explained that you were an epidemiologist and not a vaccine expert person.
I think I think everybody just assumes she knows everything about COVID. It's just a COVID all-rounder.
They think I. Exactly. I'm an epidemiologist, an immunologist, a virologist, like all these things, and I'm definitely not any of those things. But I can talk about the trials.
His question is, he's pro-vaccine. He's been arguing with people all day about taking the vaccine, and he was just asking about the hypothetical long-term risks of the vaccine.
Yes. And we're all looking at that. We've had some instances in certain flu vaccines where there's been like a long-term kind of complication of Guillain-Barré syndrome and things like that. There have been some rare, very rare cases of some long-term side effects. Overall, for the community, the risk benefit for the community is still favorable for getting a vaccine, especially in the light of the fact that we know that there are severe outcomes with the disease itself, right? If the disease itself wasn't itself, either lethal or associated with long-term complications, we wouldn't even be talking about a vaccine, right? So we have to weigh it in from a public health perspective. We look at the risk versus benefits for the whole community. And that's not to say that we don't care about the 1 out of thousands and thousands that get the vaccine that might experience a side effect. We do, but the risk benefit for the group is still there. And the trials are 2 years long, and they will be following up on all of that, and we will get a better understanding of what those are. Right now, the adverse events that we have seen in the vaccines so far there's been no difference between the control group and the vaccine group with respect to serious adverse events. So that's one thing that's reassuring. Yeah. There's been, in the vaccine volunteers, there have been injection site reactions. About 10 to 15% of the people in the trials have experienced a clinically they called it significantly noticeable adverse event, which they were injection site reactions, so like soreness at the site of the injection, headaches, fatigue, muscle aches, things like that, sort of like more malaise type syndromes, and they can last up to like a day and a half. So some people actually did feel kind of crummy after they got the first dose. It's important to get the second one, even if you didn't feel good after you got the first one, because the second one kind of the first one primes your immune system, and the second one will like just complete your protection.
Okay.
But really, the short-term adverse event profile looks very good. And then we'll be following up for 2 years on those patients. Mm-hmm. And then after that, even, I should say, and just like we do with any vaccine, any adverse events that come in go into a system, and I know you probably have the same thing in the UK. We have it in the US called VAERS, which is like the Vaccine Adverse Event Reporting System. And anything that's related to a vaccine gets reported to that. And a lot of the things that get reported are there's not like a causal relationship established, but it's reported anyway. And you can look that up. It's publicly available information.
So hypothetically, what happens if you just took half of the vaccine? Like if you just got dose one?
I don't know what happens, actually. I mean, I know that's probably discouraged because, well, if you think about it, like, so there's, 20 million doses of the Pfizer vaccine, I believe, and that will only cover 10 million people because everybody has to get it twice. So if you do that, I mean, you're kind of not letting somebody else get it that would have otherwise been able to get it, right?
Is it the same? I guess is it the same thing twice?
So for the Pfizer vaccine, it is the same thing twice.
Okay.
I'm looking right now. They have 40. So there's between Moderna and Pfizer in December. There's 40 million doses. So that's 20 million people can get vaccinated in December. Well, December, January.
Yeah.
So yes, it's the same thing twice. There's the AstraZeneca vaccine they might have to do a confirmatory trial. They may have a half dose for their their loading dose, the first one, but there was a little bit of an irregularity in the trial, whereas some of the people got there was a manufacturing error where some of the people got like a half dose, and it actually ended up working better in that trial.
Right.
So they might have to confirm that, and that's why that's not being looked at right now for emergency use, but it might be.
Mm-hmm. Next question here. Are COVID tests 100% accurate?
Oh, gosh. No, they're not. But the reason that they're very sensitive, actually. The PCR test is actually pretty sensitive, and it is a good test. The problem with the test and the problem that we have with false negatives is that the testing window is oftentimes not used correctly. And so what I mean by that is, like, if I come over to your house and you have COVID and you tell me the very next day, oh, I just got diagnosed, I just took a test and I have COVID, so I've only been exposed for one day, and I run and get a test because I want to make sure I don't have it, there's like 100% chance that I'm going to have a false negative if I'm positive if I test on day 1.
Okay.
The ultimate window of when you want to have a test is day 6 and 7 post-exposure, because we have literature that shows that your viral load is so low on days like 1 through 3 that it's like non-detectable. If you're positive, on day 4, that risk of a false positive drops, but it drops again. The risk of a false positive drops as the days go on. And then after like day 9, it goes back up, the risk. So you really need to try to, so where this becomes problematic is when I'm working every single day at like a grocery store and I have people coming in every day. How do you know when that exposure took place? You kind of don't, right? So unless you're testing regularly, it's very hard to know what window to test in. In the example I gave the first time where I'm coming to your house and you tell me you have COVID, I can pinpoint an exposure. But if I'm somebody that works in an essential worker position, or if I'm a healthcare worker, it's very hard to pinpoint my exposure. So testing negative may not be that meaningful for those people if I'm not capturing the right window. That's why the saliva test, to like just monitor on an ongoing basis when they're available to us in our homes and like to use regularly, will be much, much more informative, because you can then continue to monitor yourself and not have to worry about these windows so much.
Excellent.
So what about, so is there less chance then that if you get a positive result that you're actually negative?
Yes, there's a less. So if you're positive, you're pretty much positive.
Okay.
It's the false negatives that we worry about.
So there's no
there
chance
are
that
false
we didn't
positives, but they're much more rare. Yeah.
Oh, okay.
Awesome.
Like when the whole thing with Elon Musk, like I tested both nostrils and one was negative and one was positive, so I call BS on this whole thing. Like that whole thing that he did. I mean, all of us in the healthcare were like, you're positive, like, you know, like, because the nasopharynx, the nasopharynx is really where the virus is, and he took a saliva test. If any of those saliva tests come out positive, it's pretty much like, I mean, we just kind of all shrugged that off. But, you know, the PCR test where they put the Q-tip up your nose, where they sample that is really where the virus likes to replicate, in the back of your nose there.
Okay.
So, yeah, the PCR test is much better, but, yeah, false positives are more rare.
Yeah, there was always the worry that I might not have had COVID and I just messed up, because we done the tests at home. And
it was like 8 days in, something like that as well. It
was a bit later. It was when we already started feeling better.
Mm-hmm.
Yeah.
Okay. Well, I'll move into the next question. Is it true if someone has a common cold, they would test positive for COVID? Sorry,
no,
I love how she
with
started all these questions with, is it true? Just to start
no,
off.
you're fine. Yeah, no. I understand that these are questions people have.
Yeah.
I know it's not you asking. No, so the PCR test is not going to pick up. There are several coronaviruses, like 7, that can infect humans. The PCR test for COVID-19 will only detect COVID-19. It's not going to pick up your other coronaviruses. We had originally, our test for COVID in the U.S. was going to have all of these together, but we don't have that now. That didn't really work. So I know the PCR test that is being used is just for COVID-19.
Okay, so this is, right, I'll go ahead.
This one for Bill, I'm guessing.
No, this is still Claire. Why has China got back to normal when we've seen on the media people dropping dead in the streets and they don't require a vaccine?
Wait, I'm sorry, what? What was the question?
I think the basic thing is she's asking how China went from people dropping dead in the street to...
I didn't hear the China part.
Oh, right.
Sorry. Yeah.
Terrible accent.
So China actually China's very different from Western countries because their population got on board with public health mitigations. Like, as soon as they were told to do things, they did them. So they wore masks, they did a lockdown, they did what they needed to do, they monitored temperatures, they also they did something on their phones, I think. They did a very
like a QR app thing.
Yeah, they had like some they had some kind of contact tracing thing that was required for them to do. So they did a lot of public health mitigations that above and beyond what we're doing in the West that I think were effective for them, and they were able to get rid of I don't think they don't even have many positive cases anymore. So it gives you hope to see countries like that, and Australia, like Victoria, Australia, I think has had 0 cases now for like a month or something.
Yeah, they're doing really well.
Yeah. So it gives you hope that these can be, and it also kind of frustrates me because we look at these examples and then we see people so resistant to public health mitigations, and it's like, this can work if we all work together, but it's the people that don't want to participate that kind of keep it spreading, and it's
I think another thing is people automatically, because China's so how do we put this nicely?
Not willing to tell the media what's happening.
Yeah, so secretive. And
so there's a lot of people that, so when, at the beginning of this, it's interesting that you say that because as an epidemiologist, at the beginning of this pandemic, a lot of the data that we had on COVID-19 was Chinese. And people would say, well, that's not real data because it's from China. And I'm like, what? Like, I don't know what you're talking about. Like, it's just, to me, that's, like, I trusted the public health people in China, but there was very much resistance to accepting any data that came from Wuhan about this virus, but that was all we had, So it was like we had no choice but to take it.
I think it's the Red Scare thing again, isn't it? The communists, so automatically they're in the wrong.
Yeah, I don't have any kind of, I know what you're saying, but yeah, from a public health perspective, we really had no choice but to act on the data that we had because, the alternative was worse by doing nothing.
Yeah. Well, I'll move on to the questions from Bill.
I want to leave Bronwyn's one till last.
All right, cool.
Also, we're kind of running out of time, so we need to...
All right, sorry. Right, so this is the friend Bill, a.k.a. Mr. Long Question.
Yes.
Government experts tell us it is unlikely that we could catch COVID from letters and parcels because there is a long time between the sender touching them and the time they arrive. However, this doesn't take into account the postie and the other people in the delivery chain who have handled them much more recently.
That's a great question, actually. Fomite spread, which is on surfaces, is very uncommon, but it's not 0% risk. So there is some risk associated with fomite spread. What I do, and I don't even know if we have any great data on this, but what I personally do is when I'm getting like groceries delivered or if I'm getting the mail, I handle it with I don't wash anything down like grocery boxes or anything like that. But I do wash my hands when I'm done handling anything that comes from outside the house. And I do, if I'm like now, if I'm, I try to take things and kind of put the mail on a table and maybe not just open it all right away. But I do wash my hands really well after I handle anything from outside the house. And the same thing goes for if I go to the store. I keep a sanitizer in my car and I sanitize before I touch my steering wheel or my stick shift or any of that stuff. I just make sure that my hands are clean, and just as long as you keep cleaning your hands, the hand washing is really important for that kind of fomite spread.
Yeah. So also,
what shocked me there was an American having a stick shift car. That's the part.
I know. You know what? Nobody can drive my car, even valets. Like I'll drive up to like a restaurant and they'll say, like, "Oh, can you park your own car?" Because they don't know how to. I'm serious, because the valets are all like young kids and they don't have that. Every year I have less and less options for cars. I don't even know how to drive the other kind. They're scary. They drive by themselves. If you like put it in drive, it just goes.
I got a shot in my cousin's car. He's got an automatic, and it just feels weird.
You're not doing any work.
It's so weird. My dad taught me how to drive a manual, and I never went back. Like, I just can't.
Yeah, I don't think I'll be switching to automatic at some point. I feel like if you can't drive with stick shift, you can't drive. I feel like that's...
I think so too. Exactly.
There you go.
I grew up riding Vespas, so to me, shifting on vehicle was very intuitive to me. Like, it just made sense.
Mm-hmm. Okay.
Wish we could talk more about American
I know. I'm trying to get through these questions because I know she's not got a huge amount of time left. Apparently, it is unlikely we would catch COVID from handling cash. Why is that? Non-porous polymer banknotes in particular would appear to be an ideal surface for pathogens to survive.
I think it's the same. I mean, I think of the money as the same as like groceries and mail. Like anything you're handling that's from outside your house, I would just make sure after you handle it that your hands are clean. Mm-hmm. Like if you're getting change from a store and you get it from the person, you don't know that person wasn't just rubbing their nose and like, you know what I mean? Yeah. It's like you would just treat that cash the same way you'd treat like a piece of mail. Just after you handle it, put it in your wallet, you'd sanitize your hands and then make sure they're very clean before you touch your face or anything else.
Mm-hmm. So a question from Elric, our good friend. Is there any current social epidemiology research on COVID-19 in the UK, or even better, publicly available reports? He's spotted some happening in the US and Asia, but not here so far.
Social epidemiology. What do they mean by that? Do you know?
I don't know.
Like meaning about like depression and the effects of the lockdown? Is that what they meant?
Elric's a data nerd. He's like really into statistics. Mm-hmm. So really, if you don't know what he means, then no one will know what he means.
But I mean, the only thing I can think of is that they mean like social interaction and like with the lack of it and maybe like effects of that. I don't know if that's what the question is, but those things are definitely being studied and we know it's a significant problem. And I get accused a lot of not caring about those things because I am so pro mitigation. Yeah. But, you know, it is an unfortunate part of this. And I think there's going to be a lot of mental illness that kind of comes out of this and in complications, especially among like healthcare workers and people that have just, I mean, we're only scratching the surface of what we know about that, unfortunately.
There was a British Medical Journal article that went slightly into this in terms of just suicide. And in most like first world countries where they had money to like pay people furlough and stuff like that, suicide doesn't seem to have went up in certain countries, and in Japan it went down by about 20%. So that was shocking.
Oh yes, I did see that. Yes, I did see the Japanese thing.
Okay, one last question from me.
I keep getting people commenting that to me, and I'm like, yes, I know. We're not saying that's not a problem.
Yeah.
Right, one last question from me, and then you've got one last question as well after that. So,
you guys are asking good ones.
Again, credit. Nothing to do with us as well.
My question was the one about the stick shift.
Exactly. That was my favorite one.
Hey.
So when we talked about cheese.
Yeah.
Exactly. We just love talking about cheese. That's what we do. So
let's do another one just about cheese.
Definitely.
Down.
So this is from a friend of ours, Derek. So this was just a status he put up earlier, and I asked if I could copy it and talk about it on here. I'm not anti-vax by any means, but I am anti-getting virtually untested drugs being pumped into everyone.
Jesus
we
Christ.
Remember thalidomide, surely. Now, I've seen this meme spread earlier on about thalidomide. Could you talk about this?
So, yes, the thalidomide tragedy has, I mean, this is really, the only thing I'll say here is that we've got about 50,000 people getting this drug right now. And the trial itself has not been compromised. The science in studying this vaccine has not been compromised. What seems rushed to people, and the thalidomide tragedy was was before a lot of the regulations and the laws. It actually led to the regulations and the laws that we now operate under in the United States, and I'm sure there too.
Yes,
like 1957 or something.
Yeah, the fact that they go to 1957 says
a lot.
Yeah. So that tragedy was bad, but it actually led to a great increase in regulatory oversight of the drug development process. So this trial is being done under all the FDA, EMEA, UK purview. They know the trial protocol had to be approved by all three regulatory bodies. The trial protocols were posted publicly on the internet. That is almost unheard of and is never done. So people would be able to know that these were being done in a rigorous, randomized fashion, like the science and the statistics being done, the methodology of the trials was sound. So those two things. Plus, there is what's called a data safety monitoring board for each study. And what this is very important. The data safety monitoring board is not part of the pharmaceutical company, and it's not part of the regulatory body either. It is a disinterested third party of experts that's looking at the data in an unblinded fashion. And what that means is right now the trials are blinded. Like if I'm in the trial and I go and get my injections, I don't know if I'm getting vaccine or placebo because I'm just a trial participant and the study is double blinded, which means the doctor giving me the shot doesn't know what I'm getting and I don't know what I'm getting. The Data Safety Monitoring Board, this extra group of disinterested experts, they do know what you're getting. And they look at the data line by line of every patient and what their adverse events are. And if there is things that are related to the drug that they see as concerning, they will stop the trial. And you've heard this happen a couple of times so far where the trials have been stopped because of some kind of reaction that they want to look at. Yeah. And when that happens, people get all upset, like, oh my gosh, the trial is stopped. But that should actually make you feel good because it means they're looking at every single thing that happens. And if it goes back off of hold and people start enrolling again, it means that they found that it was really not due to the vaccine.
So, final question. And this is sort of off vaccines now. A big part of protection from COVID is track and trace. And although some countries now are starting to get the vaccine and it's going to be rolling out more next year, what do you expect to see in like the poorest parts of the world, parts of Africa, parts of like Middle East Asia, where they're probably not going to have vaccines for a while and they're probably also not going to be able to afford a lot of tests for tracking the virus?
So I know that there is a global initiative to distribute vaccines on a global scale. I don't think that it's going to be like you're saying. I don't think it's going to be right away, but there is a global effort led by the WHO to make sure that that is happening. They will get vaccinated, not in December, but soon. It's going to be an equitable distribution of the vaccine. Okay. That's the goal anyway. I know that in the U.S. we are not part of that effort, which was kind of sad to me to hear. Yeah. But I think the UK and the EU are all part of that effort to make sure that vaccines are distributed to third world countries. That being said, I actually don't know anything about how they do the track and trace or the contact tracing in those countries at all. I don't know anything about it. It's probably very difficult because I'm sure a lot of people don't have phones.
Yeah. Mm-hmm. Well, that's all the questions.
Thanks, guys. I appreciate you having me on. It's been an honor, and it's been really fun to talk to you guys. I'm sorry it's so late your time.
I assure you the pleasure is ours. We have been desperate to try and do this podcast for months.
I contacted the NHS Fife, basically the area we are in, and I sort of let them know we're a podcast and we're hoping to do a podcast the very same as this. And can we sort out a health professional that would come on and explain some of the questions that people have? Maybe we'll go over some of the conspiracy theories, because I feel that they're good to go over as well, just to keep people's minds at ease.
Yeah, I think so. Yep.
But they couldn't provide anybody. They just basically said, we can't help.
Yeah. Well, health departments, it's hard. They can't really do that stuff. And so that's why me as an academic, like, I can do whatever I want. But yeah, the health departments, they have to stay exactly on message, whereas I can say what I think.
So, well, okay, this might be a good question, quickly. So, if we want to try and get experts, would you suggest going to, like, universities and things instead of health departments?
Yeah, I think universities are better than the health department, because the health department really has they do have a communications team at the health department, but they pretty much just talk to, like, and they don't even really, if you notice, I mean, at least in the U.S., I don't know how it is there, but you don't even really see health department representatives going on the news or anything. They stay completely on message, and it has to be just like these infographics that they get. So it's really hard. But or press conferences, very official, kind of, they have to stay exactly on message. But yeah, I think academic, like schools of public health, people will usually talk to you. And anybody that specializes in infectious disease epidemiology would be a good source.
Excellent. Well, again, the pleasure's all ours. It's been great having you on.
Yeah, thank you guys. Talk to you guys again.
No problem at all. Bye.
Bye-bye.